create an involute gear form, but rather than machining it in the XY plane, we'll machine it as a Z profile. I've started the PartMaster 2D CAD system here, so we can use the involute gear function that we have within the software. So to use that, we can go into machining, involute. So this calls up the involute gear routine, so we can specify here how we want to design the gear. For a metric gear, normally it's just the module and number of teeth, but if you're using imperial dimensions, you can set things like diametral pitch, circular pitch, and so on. So we'll stick to metric, and we'll click next. So we can input the pressure angle, the metric module, and the number of teeth. So if we're designing this to be machined in the Z axis as a Z profile, we probably only need a single tooth, and we can either specify that the tooth is displayed as the tooth, like that, or as the gap. So if we go back to here, we can redesign the tooth, and we can set the module again and the number of teeth, and this time we'll have it set to gap rather than the tooth. So you'll see that now the gap is the profile. So we'll export that. We'll export it as an XML file. And then we can close down that window. In fact, I'll just export that again so it's in the right folder. Right, so that's called Gear 1, that's the XML file. Close down the gear module. I don't need to save the gear in its own right because I've got the XML file. So now here I can import that XML file, and that was called Gear 1. That's that one there. We can set the origin, so normally we'd want that to be on XY0. Okay, so that's what's come through as the XML file. Now, because we the default is that you're going to be machining this using the XY plane as a standard mill or wire EDM program, it's automatically created the tooth form as a contour, but we don't want it as a contour, we need it as a profile. So what we need to do is to explode it back down into its base elements, and to do that we use curve, break apart, or extract, and then we click on the profile, the tooth form, and it will separate that gear contour into separate line and arc segments. And now we can create a profile of that. So we use the NC mode, the datum, which will be the center of the bar which the tooth is going to go round, and we want to create an NC profile. So if I just zoom in on there, this will be the start point of the profile. It's not closed, so I need to give it the end point, which is there, and that creates a Z profile for me. So I'll save that away. And call it Gear Z Pro, and we'll take that through into machining. Okay, we set up, this is the machine setup, so we can put in a program ID or a program number, set the tool change and the clearance plane. Make sure that the clearance plane is above the radius of the bar that you're going to be putting this round. So we define a tool, so let's have quite a small tool, I would think. Okay, so we can use an end mill, a ball nose mill, or we can use an end mill with a tip radius on it as well if we want to. So that's the tool defined. Now we can select that tool for use, set the spindle speed and the feed rate, and then we'll use the Z profile command Now, depending on what it is you want to do with this or how it needs to be machined, let's first of all just produce a simple Z profile as a slot. We may need to machine in the reverse direction. This thing here is quite important, the vector tolerance. The smaller you have that, the greater the number of individual Z and X and Y and X moves you're going to create. So set it to a fairly sensible number, not a tiny number, because you'll end up with a huge, great big NC program. So this is just doing a single slot. If you want to create a surface, then we would just put in the distance between alternative slots and the number of the slots that you need. But if we concentrate just on a single slot at the moment, then you'll see what happens. Okay, so what that does in effect is it puts the slot on 0, 0. So we need to move the slot such that it's going to start here where we want it, depending on the radius of the bar. So if we go back into the CAD, then we just need to get a couple of dimensions off here. So if you go into dimension and make sure we're in near snap, hold down the shift key, click on the end point there and the center point. So that gives me the X offset. So if I go back into the cam, now I can use that. So the start point in X is minus 4.81. So that's moved it across in X. Now we need to move it up in Y. Oh, sorry, it's 4.18, not 4.81. Minus 4.181. That's it. Just run that. Okay, and now we need the vertical. So that's there and there. So that's in near snap. So that's 39.781. So if we go into here, the work surface is 39.781. Okay, so as you can see now, if we go into the front view and just zoom in on there, okay, so that's the center line of the tool. If you want to animate the tool, you'll see the effect of the tool moving down into there. Now obviously the tool would need to be small enough to get into the bottom of here. If you have any rads in the corner here, any fillet radiuses, then obviously the tool would need to reflect that. If you wanted to change that into a surface, then by double clicking on that you can set the number of the distance between the slots, and you can give it a number, let's say 10. Okay, now I might need to change my angle on here, we'll see when we run the simulation. Okay, slots. Oh, I want to create a rolled surface, I forgot to do that. Okay, so it's just... Okay. So that now creates a surface which can be used for the thickness of the component. Now if you're looking at putting this around a bar, then obviously you need then to move the bar around and then run the program again, depending on the angle between the teeth. Okay, so that's how you do that.